All right, welcome to the deep dive. You've been exploring how digital tools are used in education. Sent over some really interesting stuff.
Yeah, definitely some thought-provoking material there.
So what we want to do today is maybe go beyond just, the fact that tech is in the classroom
Right.
and really try to understand why and how these tools can actually, well, make learning stick.
Make it effective, yeah.
It's not just about having a fancy gadget, is it? It's about what that gadget does.
Exactly. And when we say digital tools, I mean, that's a huge range, isn't it? Software, hardware,
All sorts.
used in loads of different ways. But the crucial point, I think, from your sources and what we should focus on
Mm-hmm.
is that the sort of magic, if you like, isn't the tool itself.
Okay.
It's the specific instructional features built into them. Things like adaptive feedback,
What feedback tailored to
or
you?
prompts, scaffolding, and of course, how teachers and students actually use those features, that interaction piece.
So the potential is one thing, but the actual impact depends on the design and the use.
Absolutely. The big takeaway right up front, it's not the tech. It's the instructional design within the tech that counts.
Right. There's that gap between cool app and actually helps me learn. So to help us unpack this, we're going to use a framework from one of the articles in the Educational Psychology Review.
That's the one. It's called the Cognitive Process Framework for the Mechanisms of Learning with Digital Tools. Bit of mouthful.
Yeah, let's call it CODIL. Sounds better. So, okay, let's dig into this CODIL thing. What's the core idea?
What's really neat about CODEL, I think, is how it pulls together ideas from different fields.
Like what?
Well, instructional psychology, how to teach effectively. Cognitive psychology, how our brains actually process information. And even domain-specific education research, how learning math is different from learning history.
Okay, so it's trying to connect the dots.
Exactly. Think of it as a lens. It helps us answer two key questions. What specific things in this digital tool are supposed to help me learn? And how does my brain actually use those things to build understanding? It looks at the interaction, the behavior.
So it helps with designing tools and understanding how students learn with them.
Precisely. By analyzing those interactions with specific features, we can get insights into the learning process itself.
Okay, so underlying all this is the fundamental idea of how we learn. Codil starts there, right? Saying learning isn't passive.
Right. It emphasizes that learning is active, constructive. You're building understanding, not just receiving
And
it.
it's content specific too.
Very much so. What you're learning matters. This isn't, a totally new concept. It builds on lots of established learning theories.
And it introduces this term, knowledge components. What are those exactly?
Yeah, knowledge components. Think of them as the basic units of knowledge or skill.
Yeah.
The building blocks.
Like mental Lego bricks.
That's a great analogy. Yeah, like Lego bricks for understanding.
Yeah.
The article mentions schemata, which is a similar idea, mental frameworks.
Okay. And why are these components important?
Well, they define what mastery looks like for a topic. They help you activate what you already know, your prior knowledge. And crucially, they change and develop as you learn. They evolve.
Right. The article had that example with fractions comparing 23 and 45. How do knowledge components fit in there?
Okay, yeah, fractions. So when you first see that problem, you bring existing bricks knowing about whole numbers, maybe the part whole idea.
Stuff you already know.
Right, prior knowledge. But then, as you start learning, you might build some, let's say, incorrect or incomplete bricks, like just comparing the numerators, the top
We're
number.
just the bottoms, yeah. I remember doing that.
We all do. So the learning process is about revising those faulty bricks and building the right ones, the correct strategies for comparing fractions. That's the final knowledge structure you're aiming for.
So understanding these specific bricks for, say, math versus science is key for designing good teaching, especially digital tools.
Absolutely essential. If we know the common misconceptions, the typical learning path, we can build tools that address those directly. The article mentions cognitive student models.
What are those?
They're basically models of how students tend to think about a specific topic. The typical steps, the likely errors, they act as guidelines for design.
Makes sense.
Well-
Target the known sticking point.
Exactly. And we can't forget prior knowledge in all this. It's not just subject knowledge, but also like general experiences, attitudes, interests.
And the background stuff you bring.
Yeah, it massively predicts how you'll select new information, how you organize it, how you integrate it with what's already in your head. It's foundational.
Okay. So learning is active, uses these knowledge components, builds on prior knowledge, but just having a learning opportunity isn't enough, right? You have to actually use it.
Precisely. That brings us to the next piece, the utilization of learning opportunity framework. ULO.
ULO.
It sounds a bit academic, but the idea is simple. The effectiveness of any learning environment depends on both its structure and how students actually engage with it. You need both.
So great tool, no engagement, not much learning.
Pretty much. For good outcomes, students need to actively do something with the learning opportunities offered. This ties back to that active, generative view of learning.
Generative learning, like generating understanding yourself.
Exactly. Theories of self-regulation also fit here. It's about the learner's activity during instruction. Are they actively building with those Lego bricks?
And for digital tools, the article stresses focusing on specific learning activities, not just engagement in general.
Yeah, that's a crucial distinction. Clicking around or spending time isn't the same as, say, trying to explain a concept to yourself. We need to look deeper than just usage metrics.
So what are some of these specific learning activities relevant to digital tools? The article lists quite a few.
It does. Let's touch on some. There's abstraction, seeing the pattern in specific examples to grasp a general rule.
Okay, finding the concept.
Then conducting experiments. Think virtual science labs, using the tool to gather data and test ideas.
Hands-on, but digitally.
Right. Creating examples is another one, making your own instances of a concept to understand it better. Its boundaries, how it works.
Like if you're learning about triangles, drawing different types.
Exactly. Exploration is important too, just actively poking around in the learning material, activating prior knowledge, maybe sparking questions.
Getting oriented.
Yeah. Then you've got things like formulating hypotheses, refinement, which is making your understanding more precise.
Sharpening the knowledge.
Revision, which is
Yeah.
more fundamental, like restructuring a whole concept you had wrong.
A bigger shift in thinking.
And self-explanation. That's a big one. Explaining the material to yourself, maybe summarizing, drawing inferences. It forces deeper processing.
These all sound like things your brain has to actively do.
That's the point. They're the cognitive link between interacting with the tool externally and the internal process of knowledge building.
And digital tools, being interactive, seem well suited to support these.
Potentially, yes. And this leads right into why some tools work. It's about the instructional features they implement.
Ah, okay. So not the tool itself, but what's inside the tool that prompts these activities.
Exactly. This ties into that old media debate, Clark versus Cosma.
Right, right.
Hmm.
Does the medium matter or just the teaching method?
Yeah. Clark basically said the medium is just a delivery truck. Cosma argued different media have unique capabilities that can influence learning.
Where does Coder land?
It kind of bridges the gap, but leans towards Cosma's side in a specific way. It says it's not the digital nature per se, but the digitally enriched instructional features that matter.
Okay, features again.
These features are like specific events designed to offer learning opportunities. They have affordances, things they enable, and constraints. Their goal is to trigger those learning activities we just discussed.
How? By managing brain power.
In a way, yes. By reducing unnecessary mental load, extraneous load, and encouraging that active generative processing, making sense of the material. This aligns well with the cognitive theory of multimedia learning.
Okay, so can we get concrete examples of these digital features and the activities they might trigger?
Sure. Think about adaptive feedback.
Feedback that changes based on my answers.
Right. That can really stimulate refinement and revision. If you get something wrong, good adaptive feedback doesn't just say wrong. It might hint at why, activate relevant prior knowledge, or point out a misconception.
Pushing you to fix your understanding.
Exactly. Or consider tools that let you try and fail on problems before instruction. Sometimes called PSI, problem solving before instruction.
Learning from mistakes first.
Yeah. This can strongly stimulate exploration. It makes your current, perhaps flawed understanding really salient, highlighting what you don't know yet. It creates a need to learn.
That sounds powerful. What else?
Prompting. Little nudges or questions from the tool. These can encourage refinement by asking you to elaborate, or maybe stimulate self-explanation by asking you to summarize or connect ideas.
Like a little tutor looking over your shoulder.
Sort of, yeah. And contrasting cases, showing you two examples side by side that highlight a key difference.
Ah, to spot the critical feature.
Right. This is great for stimulating revision. It forces you to compare, identify patterns, see the limits of your current thinking, and adjust your mental model.
Interesting. Now, some of these features, like feedback or asking questions, teachers do that without computers.
Absolutely. Good teaching principles often transcend the medium.
So why are they particularly promising in digital environments, according to the article?
It often comes down to affordances of the digital medium. Scalability, immediacy, personalization.
How so?
Well, adaptive feedback can be instant, specific to your exact error, and delivered privately, something hard for one teacher managing 30 kids.
True.
Simulations allow conducting experiments that might be too dangerous, expensive, or time-consuming in reality. Digital tools can often implement these features consistently and adaptively at scale.
Okay, so digital offers unique ways to deliver these known good instructional techniques.
That's a good way to put it.
So we've got features triggering activities, leading hopefully to learning. But how do we know this chain is actually happening? How do we connect the clicks to the cognition?
That's the million-dollar question, isn't it? And a key focus of Codil. A lot of research just looks at use tool X, get better test score.
Right, the bottom line.
But that skips the why. Codil says we need to look at the behavioral side, the actual student-tool interaction as the mediator, what the student does with the features.
The interaction is the evidence for the thinking.
It's an indicator, yes. The observable actions, clicks, typing, navigation paths, time spent can provide clues about the underlying latent cognitive processes. Are they self-explaining? Are they refining?
And this is where process data comes in.
Exactly. Process data is broader than just simple log files. It can include keystrokes, solution steps, maybe even eye tracking data.
Where are they looking?
Right. Or finger tracing on a tablet. Think aloud protocols where students voice their thoughts.
Wow, lots of possibilities.
Or even journal entries. The crucial thing is, you need a good theoretical reason to believe a certain interaction pattern reflects a specific cognitive activity. You need appropriate indicators.
Can't just collect data randomly.
No, you need a framework like Codil to guide what you look for and how you interpret it.
The article contrasted two studies on this point, didn't it? One less successful, one more aligned with Codil.
It did. There was a study comparing virtual frog dissection to real dissection. It found the virtual tool worked well, but didn't really dig into which features drove that or what learning activities students engaged in. It missed that mediating link.
To show it in effect, didn't explain it.
Pretty much. But then there was another study on a formative assessment tool for math that provided adaptive feedback and practice. That study did a better job. It hypothesized how the features should help, measured how much students actually use the tool as a behavioral indicator, and found that more usage correlated with better learning outcomes.
Connecting the dots.
Yeah.
A feature usage outcome.
Exactly. That's much more in the spirit of the Codil framework, trying to understand the mechanism.
So wrapping this up, what are the big implications for people actually designing or choosing digital tools for education?
Well, the Codil framework offers a guide for both development and evaluation, really.
For development.
Start with the learning goals. What specific knowledge components do you want students to build? Then, what learning activities support that? Then, design or select instructional features in the tool that are explicitly aimed at fostering those activities.
So learning goals first, then activities, then features.
Right, like building that online math tutor. Focus on features like adaptive feedback to drive refinement, creating a physics simulation, build in robust ways to conduct experiments.
And for evaluating existing tools.
Don't just look at final test scores. Analyze the process data. How are students actually interacting with the features? Are they using them as intended? Are they engaging in the target learning activities? This tells you why the tool might be working or where it falls short.
Gives you much richer feedback than just a score.
Absolutely. It helps us move beyond just adopting tech and towards strategically using it to enhance cognitive processes.
Okay, so to quickly recap for everyone listening, the effectiveness of digital tools isn't magic. It's about specific instructional features.
Right. Features designed to trigger active cognitive learning activities.
And this whole process is shaped by what you already know and how you actively engage.
And the Codil framework gives us steps to think about this. Define the knowledge, identify the activities, design select features, and then measure the interaction of the process.
So here's a final thought for you to consider. Look at the digital tools you use, maybe for work, learning, or just life. What specific features do they have?
Big question.
And what kinds of thinking or learning activities do those features seem to encourage? Or maybe even discourage?
Yeah, does that feedback feature actually make you think or just click next?
Exactly. How could understanding these mechanisms, the features, the activities, the interaction, help you, maybe as a learner or an educator, navigate this digital world more effectively? It's about getting past the shiny surface.
And focusing on the cognitive substance underneath. How does this actually help us think and learn better?
Definitely food for thought. Thanks for diving deep with us today.
My pleasure.
We hope this gives you a clearer lens for looking at learning in our increasingly digital world.